Hi class. Today I don't have any formal notes for you. This video won't be quite as long, but I wanted to show you a special factorization that you need to be aware of. So it's called the different, oops, sorry, I need to get my pen going here. Sorry about that. It's called difference of perfect squares. So I'm just going to put diff of perfect. I'm going to put a square. Okay, we know what perfect squares are. Perfect squares are things like 9 and 16 and 25, something that you can take a square root of, and it comes out as just one number, not a decimal or a fraction or anything. So, for instance, x squared minus 9. Okay, x squared is a perfect square because x times x equals x squared, or the square root of x squared equals x. Okay, so this is a perfect square. Okay, 9 is a perfect square. We know that 3 times 3 is 9. And then the difference part indicates subtraction. Okay, this does not work for addition. This is only for the difference of perfect squares. So first I'll show you why this works. So this is a quadratic, right? There's no linear term, or the linear term, the b value is just 0. It's still a quadratic, it's a square term, and then there's a constant as well. So I still want you, when we're first showing this, I want you to recognize it when we eventually that this is the difference of perfect squares, and you know how to factor it just like that. But right now I want to show you why it works. So we'll identify that a is 1, and that b is 0, and that c is 9. Okay? Actually, it's negative 9, isn't it? It's negative 9. So when we know that when a is equal to 1, we have to find factors of c that have a sum of b. In this case, 0. So factors of negative 9 that have a sum of 0, we can quickly see that it's negative 3 and positive 3. They have a product of negative 9 and they have a sum of 0. And so it factors like this: x subtract 3, x plus 3. Okay, that is the difference of perfect squares. So I want you to think about that. Then I'm going to scroll down here a little bit. I'm going to give you another one. So let's use x squared minus 25. Okay, using the model that we just did, so let's do that. Using the model that we just did, what do you think that's going to be? Think about that. You could certainly identify, you know, your A, your B, and your C, but I want you to get to the point where you don't need to when it's the difference of perfect squares. So in this case, we know it's going to be x subtract 5, x add 5. Okay, and of course you could have it the other way. You could have it like this. Okay, either one is fine. Okay, now I'm going to show you one that's a bit more difficult. So let's think about this. What if, oh fiddlesticks, hold on, sorry guys. Oh fiddle, I'm just going to return for a while. There we go. Okay, what if I had this? What if I had x, Julie, well, I had x to the 4th minus 1. What if I had that? Now this is not a quadratic, but is it a difference of perfect squares? What's the square root of x to the 4th? What times itself equals x to the 4th? Well, that would be x squared, wouldn't it? Okay. All right, so then I would get x squared minus 1, x squared plus 1, wouldn't I? Because 1 is a perfect square, so x to the 4th subtract 1 is still the difference of perfect squares, and so we use that same format. Okay, now, this is where it gets a little trickier. Take a look at what we just did here. What do I have there? Is it another difference of perfect squares? Is x squared a perfect square? It sure is. We just did it. Absolutely. So this then factors to x minus 1, x plus 1, and then we have to bring this guy back down, x squared plus 1. Okay. It also works if we have coefficients. So let's say we have 25 a to the second squared minus 36. Okay, we've probably noticed the pattern. You know the a and the a are going to be here. And what you're just doing here is just taking the square root of 25, which is 5. One of these has to be plus, one of these has to be minus, and then the square root of 36. There's that one factored for you. This is just difference of perfect squares. Okay, let's keep going. Let's do I don't know, 4x to the fourth minus 9. Is this the difference of perfect squares? Is 4 a perfect square? It is, because 2 times 2 is 4. Is x to the fourth a perfect square? It is, because x squared times x squared is x to the fourth. And 9 is a perfect square, and it's the difference. So, put our parentheses, we put our x, take the square root of 4, put our 2. Now we know, I just said that it's x squared times x squared. We take the square root of this, which is this and this. One is plus, one is minus. Take the square root of 9, 3, negative 3. Now we look to see if we can factor it further. We cannot, right? Because 2 is not prime, or a perfect square, and negative 3 is not a perfect square. So these are what we end with. Okay, so those, I want you to understand that relationship. That will save you lots of time in the future, not just with this class, but in the future when you're factoring larger numbers. If you always look for the difference of perfect squares, it's going to save you some time, kiddos. Okay, you can always identify A, B, and C and see that B is 0, and then come up with factors for C so that they cancel out or equal 0 when you add them. But it's good if you can identify the pattern and then remember that. So I wanted to share that with you. The assignment that I'm going to post for that is just dealing with perfect squares. Thanks, guys.